that are used for cloud computing. Some of them we've seen last time. We will look at Hadoop and MapReduce, but also other tools such as Pig, Hive, and HBase. So, about Hadoop, we'll talk about the basics. We will look at the distributed file system and why do we need Hadoop distributed file system. What is the goals and the purpose of that, how it is organized, how it is constructed, and its architecture and what features it has. And then we will look again at the MapReduce basics, how that is organized, and that example of the word count, and also another example for finding the shortest path algorithm. These other projects are related to, they are sub-projects of Hadoop, Pig, HBase, and Hive, that are Apache projects, and we will look at those as well. As an introduction, then we have separate lectures to those. So what was the purpose of creating this cluster of computers? Why do we need this? Because it's difficult, it's difficult to build reliability into each application if we have a bunch of machines connected together, and those are inexpensive commodity machines, and any of them can fail at any time. So the failure is expected, and we plan for that to happen. So if one of the nodes fails, or if one of the machines fails, then that is expected, and we have a way to replace that. And if any of the pieces of the files are lost, then we keep a number of copies of them so we can replace them. Now these machines are connected to each other through a network. So the network itself has to be maintained and decide what kind of network parameters we're going to use to connect these machines. So it has to be reliable and easy to use. Who is using this kind of system? So these are all organizations that have a large number of users connecting to them and requesting information. And so these are servers that need to serve many requests per minute and need to have access to a lot of files. So all of these organizations use Hadoop to serve their customers. So Amazon, Facebook, Google, the New York Times newspaper, Yahoo, and many others. So when the size of the data gets that big, and we have that many customers per second that is trying to access these documents, then we need a cluster of computers, because it's no longer feasible to serve these requests with, let's say, some huge mainframe machine as we are used to doing in the past. We have seen this last time. That's just another picture of it. This is the architecture of this clustered environment. So there we have nodes. So this is an individual machine, and that has a CPU, memory, and a disk, and there is a number of them organized in a rack. This right here is a switch. That's an Ethernet switch, so the machines are connected to the switch through a network cable, and this switch is connected to another aggregation switch that has access to all of the switches or racks. So the rack switch controls the nodes that are part of this rack. So these are machines connected together through the network. So we have a two-level architecture. The nodes is just a commodity computer, which means it's nothing special about it. It's cheap. It doesn't have very high capacity hardware on it. So these are called commodity computers. They could be 30 to 40 of those nodes connected to the rack switch. The speed of this network connection is 3 to 4 gigabits per second. The connection of the rack to the aggregation switch is 3 to 4 gigabits per second, and the internal rack is 1 gigabit per second. So this is slower than that link. The green link is slower than the red link. So why do we need the distributed file system? Hadoop distributed file system, or HDFS? Okay, so we have now a bunch of computers. Our data can be stored in any of these nodes. They are connected through a network. Well, a normal file system that we're familiar with on our laptops resides on a single disk. And so the file system is organized in a directory tree structure. So we have a top of the tree, and then underneath are linked other directories. Usually it's the root directory, and other directories are underneath, and then the files are inside of the directories. So that's on a single disk. Now, if we want to have a file system which is spread among multiple computers connected through a network, then we need a little bit more complex design of that file system. And that's what the distributed file system is. It makes all of these computers connected together appear as a single file system. So no matter where the file is, we can access it through this distributed system. So it assumes the commodity hardware. It does replicate the files in case there is a failure, because we expect that there is going to be a failure. And this system is designed for batch processing, which is different from the file system that is on all of our laptops. That's not designed for batch processing. So this system, most of the jobs are batch jobs. So they designed a file system for this type of processing. So the data locations are exposed so that computation can move to where the data resides. Let's see how this looks like. So there is a single namespace for the entire cluster. The data is divided into blocks. If you look on your file system, the block is probably like 512 bytes. Over here we have 64 megabytes up to 128 megabytes. Why would we want to have such a big block? If you have this kind of block on your laptop, are most of the files that we create that big? If not, they're going to take up the block and the rest will be wasted. So that's not very appropriate for our laptop's file system. But here, it optimizes the seek time. So if we're going to because these machines are connected through a network, it takes a long time to search for the file compared to the time it will take if you just search your hard drive for the file. And that takes a long time, and you want to optimize that. And the bigger the file size is, the less number the bigger the block size is, the less number of blocks we have to search for to get the entire file. So remember, the file will be broken into pieces if it's bigger than the block size. So it was it was estimated that the optimal size of the block is 120 megabytes, 128 megabytes. So each block will replicate on multiple data nodes, and we mentioned last time that it's replicated 3 times in case of failure. The model is write once, read many times access model. This is to handle the streaming data. So streaming data means write it one time and then many times it will be accessed. Similar to videos on YouTube. If you know, once you upload the video, and then many people will watch it and access it. Client can only append information to the existing files. The client is intelligent because it can find location of the blocks and accesses the data directly from data nodes. So we have the client is invoked on behalf of the user, and the client is going to go and seek the block pieces in these data nodes for us. We will see more details of that architecture in the next lecture, in the HDFS lecture. So there is a master node, name node, which is contains, is very similar to the root directory on the regular file system. So it contains the information about all the subdirectories of the directory tree and where they're located and how to find them. So this master name node has the metadata, name and replicas of all the files. So it can access, it tells where they're located. The data nodes contain the actual blocks of the files, and they are the ones who perform the operations on the files. So they will open the files, close the files, update the files. The client is invoked on behalf of the user. So if the user wants to read or write anything to the files, this client is invoked and it reads. So it can contact the name node, master node, to obtain the location of the blocks of the files in the data nodes. If it wants to write, it can write to them, or it can read them. So the rack, as we mentioned, can have a number of data nodes, and these data nodes contain the blocks of the files, and they are the ones who perform the read-write operations on them. The name node contains information about all these data nodes and where they are located and where all the blocks are.